All right, so let us begin. All right, so objective today is to attempt 60 multiple choice questions and try to understand why we get the answers that we get. I will go through them, and as I go along, you let me know how you're understanding and how it is making sense to you. So let's start with question 1. Which of the following movements depicts Brownian motion? And they give us 4 options. You have pollen grains moving at random in water. B, water moving from seawater into brine through cellophane. C, the scent of perfume moving through the air in a room. And D, the movement of sugar particles into the bloodstream through the intestine wall. Now, when we consider Brownian motion, there's something that we first need to figure out, right? And that is the gentleman by the name of Robert Brown in 1855 was lying down in his room when a streak of light came in through the window. And as he saw the streak of light coming in, there was some dust particles moving randomly. And the thought hit him that the dust particles were being continuously bombarded by air particles. As a result of that, we understand that the zigzag movement of small particles suspended in either a gas or in a liquid is referred to as Brownian motion, right? So when particles move in a zigzag movement, they are continuously being bombarded, and we refer to that concept as Brownian motion, right? And the best evidence for the existence and movement of particles in a liquid, Robert Brown was able to show that, right? And this phenomena is called Brownian movement. So if we go back to the question that is being asked now, right? The question asks, which of the following is depicting Brownian motion? So we're looking for something that is saying it is moving randomly, right? So when we look, pollen grains moving at random in water tells us that it's Brownian motion. When we look at the second option, water moving from seawater into brine through cellophane. No, the cellophane acts as a membrane, and water moving from one part to another is the movement of water, that's osmosis. The scent of perfume moving through the air in a room, that is diffusion. And the movement of sugar particles into the bloodstream through the intestine walls, that would require some form of energy. It might be active transport of some kind. So B, C, and D is not our options. That leaves us with A. A as in apple is our answer to this question. All right, so number 1, A is our answer. All right, cool. Question 2. The arrangement of electrons in atoms of X and Y are 2, 8, 5, and 2, 8, 6 respectively. So which of the following options represent X and Y? Now, if we look at it, they have 285 and 286. Now, what does that tell us about anything? When we try to identify whether something is a metal or a non-metal, there are a couple of things that we have to first consider, right? That being, on the left-hand side of your periodic table, this part here, you're dealing specifically more with metals on this side here, right? You're dealing with metals. These are your metals. In the middle here, you have metalloids. And on this side, we have our non-metals, right? So we have metals, metalloids, and non-metals. Metals have 1, 2, or 3 electrons in its outermost shell, right? This middle part here, these are your transition elements. And this is group 1, group 2, and this is group 3. And in the middle here is transition elements. So metals, generally speaking, have 1, 2, or 3 electrons in the outermost shell, while non-metals tend to have 5, 6, or 7 electrons in the outermost shell. Well, when we reach the 8, we are talking about inert gases. They have completely filled shells, right? So we have metals, non-metals, and we have metalloids. So what does that have to do with what we are doing? When we consider the valence shell or the outermost shell, that valence shell is the shell that is on the outside of any electron, of any element, sorry. So the outermost shell of an atom is what is referred to as the valence shell. So this is where any chemistry that has to take place will take place, in the valence shell. So what is the note? Metals have 1 to 3 electrons in the valence shell, while non-metals have 5 to 7 electrons in the valence shell. Coming back to the question, X have 2, 8, 5. So it has 5 electrons in the valence shell. And this last value is reflective of the valence shell. So X is most likely a non-metal. The next element, Y, is 286. The 6 means to say it has more than 3 electrons in the outermost shell. So we are most likely, again, dealing with a non-metal. So element Y is also a non-metal. The option that says both of them are non-metals is B. X and Y are non-metals. So our answer for question 2 is B as in boy, because in the valence shell, they have 5, 6, or 7 electrons in the outermost shell. All right, good. Okay, question 3. Item 3 refers to the following graph, which shows the changes in temperature with time for a substance that is heated until no further physical change takes place. Now, when we look at it here, we see it starts off at this point, then it plateaus off, right? You have a flat line, then it begins to increase, then it plateaus off, you have another flat line, and then it begins to increase again. And they ask us, during which portion of the curve is the substance a liquid alone? Right? Now, this here is a heating curve, meaning it will start off as a solid, then it will be a solid liquid, the solid begins to melt, then it becomes liquid, then it becomes liquid gas, and then it becomes gas completely. Right? That's basically how the heating curve looks like. So let me pull up an example of that for you. Your heating curve, so it starts off as a solid, for example, if you had ice, and then you take the ice out of the fridge, what begins to happen? The ice begins to melt. So you have some ice and some water. And at that point there, this here, the ice is melting. So this is your melting point, right? This point here is your melting point. But then when all the ice has melted and has become water completely, you enter this phase. So when it's all water, the temperature now begins to rise. As the temperature begins to rise, again, the temperature stops rising as the water begins to be converted to gas. So you have some water and some gas particles. The point where all the water is converted to gas, that point is your boiling point, right? And therefore we have gas alone. So it begins to increase again. So coming back to our question, during which portion of the curve is the substance a liquid alone? That portion of the curve is this third portion right here. So our answer should be C as in cat for this question. C as in cat, 3. All right, question 4. The mass number of an element is the number of particles in the nucleus of an atom of that element. So particles refers to, and they want us to try and figure it out. So what we know about atoms or elements, you have 3 subatomic particles. You have protons, you have neutrons, and you have electrons, right? We have 3 subatomic particles. Now inside of the nucleus, we have protons and we have neutrons. And orbiting the nucleus, we have electrons, right? So electrons orbit the nucleus and they do that in electron shells, right? So they orbit the nucleus in electron shells. So when they speak of particles in the nucleus, they are referring to the protons and the neutrons that are inside of the nucleus. So the question asks, the mass number of an element is the number of particles in the nucleus. So we have protons and neutrons in the nucleus. So protons plus neutrons supposed to equal to the mass number. So coming back to the question now, when we try to figure out what is the mass number, it should refer to the number of neutrons and protons, or protons and neutrons, whichever order you have it written down. That would be the answer to that question. All right, question 5. Which of the following elements has 7 electrons in its outermost shell? So in order to know that, we need to know what the electronic configuration of each of these elements are. Hydrogen is the number, the first element in the periodic table, so hydrogen is 1. Oxygen is 6, so oxygen have 2 electrons in its first shell, and it has 4 electrons in its second shell. Nitrogen is 7, so it has 2 electrons in the first shell and 5 electrons in the second shell. And chlorine is 17. It has 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the third shell. So this means to tell us that the most likely response we're looking for is D as in dog. Chlorine is expected to have 7 electrons in its outermost shell. All right, so if we were to look at a diagrammatic representation of these elements, it would look something similar to this. And chlorine here, it has 1, 2, 3, 4, 5, 6, and 1, 7 electrons in its outermost shell. Hydrogen would only have 1, nitrogen will have 5, and oxygen would have 6. So the correct answer for this one is chlorine. All right, so our answer is D as in dog. Question 6. In the equation, so they give us an equation there, right? X KOH plus 3Br2 to give you Y KBr plus KBrO3 plus 3H2O. And they ask us to find the value of X and Y respectively. All right, now in order to do that, the number of reactants must equal to the number of products. However much reactants we have, or elements we have on the reactant side, it must also equal to the elements that we have on the product side. Now, in order for us to figure out that, we need to choose the options. So go by a process of elimination and see which one will cause the elements on either side to balance off. So let's start off with the first one, where X is 5 and Y is 6. So when X is 5 and Y is 6, let's check and see how much of each of the elements we have on either side and see if they're balancing up. So if X is 5, on this side I have 5 potassium. On this side I already have 6 potassium. So already we have a problem, because I don't have any more potassium on this side, but I already have 6 potassium and I have a next potassium here. 6 plus 1 is 7. So where X is 5, it's not possible to balance the equation. So we need to look for an option now where X is not 5, where X is 6. So let's look for where X is 6. So A is not our answer, and C is not our answer. So that leaves us with B and D, right? So when X is 6, Y is equal to 5. Let's try that one. When X is 6 and Y is equal to 5, on this side I have 6 potassium. Over here I have 5 potassium plus 1. So I have 6 potassium on this side as well. So let's check the oxygen. I have 6 oxygen on this side. On the opposite side, I have 3 oxygens here. And I have 3 oxygens here. Right? 3 2s are 6. So the oxygens balance off. So the potassium is balancing off. The oxygen is balancing off. So that leaves us now with hydrogen. Here I have 6 molecules of hydrogen. On the opposite side, I have 3 by 2 is 6 hydrogen on this side as well. So the hydrogen is already balancing off as well. So potassium balances out, oxygen balances out, hydrogen balances out. So that leaves us now with bromine. I have 3 Br2, so that's 3 by 2. I have 6 bromine atoms. On the opposite side, I have 5 bromine here, plus 1 bromine there. That means I have 6 bromine on this side. So on either side, the bromine balances out. So our most likely answer is B as in boy, X is equal to 6 and Y is equal to 5 because it balances out. Right? So answer should be B as in boy. Cool. Okay, so basically, the concept of this question, all the reactants must equal to all the products, right? Whatever you have on the reactant side should equal to whatever you have on the product side, which would give us the answer. And the most likely answer, as I said, for this question is B as in bat or B as in boy. Question 7. Of the following ions, the one which requires the largest number of moles of electrons to liberate 1 mole of it is what? So they're asking the one that requires the largest number of moles. Now, aluminum is Al3+. So if I were to draw my number line, all right, in the middle here, I would have 0. Going this way, it's +1, +2, +3. So to produce aluminum +3, I would need to lose 1 electron, 2 electrons, 3 electrons. All right. Going in the opposite direction, I have chlorine. Chlorine is Cl-. So this here is -1. So if I were to go from chlorine as an atom to chlorine as an ion, I need to lose 1 electron. So aluminum I would need to gain an electron for the chlorine. Aluminum requires the loss of 3 electrons. So aluminum must lose 3 electrons. All right? While chlorine must gain 1 electron. Copper is Cu2+, so it would most likely gain lose 2 electrons. So copper is 2 electrons. And oxygen needs to gain 2 electrons. So copper is losing 2 electrons while oxygen is gaining 2 electrons. So the one that has the largest number of electrons in terms of moles to liberate 1 mole of the elements that they have here, the one that is the largest is going to be the aluminum. Aluminum requires 3 electrons to be lost. So for it to move from aluminum, Al, as an atom, to become aluminum as an ion, Al3+. Or to move from Al3+ back to Al, it needs to get 3 electrons. Either way, aluminum would require the most amount, which corresponds to the largest number of moles of electrons. Right? I want you to see that. It's the moles of electrons that they're referring to. So, if I were to use equations, it would be aluminum Al3+ aqueous plus 3 electrons to give you aluminum solid. So by adding back 3 electrons to the aluminum, it becomes back the atom of aluminum. The chlorine ions, Cl2-, the Cl-, it would minus an electron to give me chlorine gas, right? The 2 here and the 2 here is just to balance the equation because chlorine does not exist by itself in the atomic state. It exists as a gas. So it becomes Cl2 gas, but it's still 1 electron is being lost for each atom of chlorine. So this here is 2 electrons. The copper is, to go from Cu2+ to copper, and in the atomic state, it needs to gain 2 electrons. And to go from O2- to oxygen, it needs to give up 2 electrons. Either way you're looking at it, aluminum still has the largest number of electrons that needs to be liberated. All right, so our answer to this question is A as in apple, because aluminum is Al3+, while the others are either -2+ or 2-. All right, question 8. Now, question 8 requires, this is testing on the ability for you to remember what the definition of a mole is. And then they take a portion of it and put it into the question to see if you know what that is. So the quantity 1 mole of atom of an element refers to the mass of, and they have one atom of the element. Now this is correct, but it needs more information to it. This is too vague. So even though this is partially correct, it's too vague. Part B, the element which contains 6.0 by 10 to the 23 atoms, again, this is part of it, but this is not 100% correct. This is missing something again for us to say that this is right. The element which occupies 24.0 dm³ at STP. Now, at RTP is 24, at STP is 22.4. All right, you have room temperature and pressure and standard temperature and pressure. This one's supposed to be 22.4, but either way, again, it does not address exactly what the quantity of 1 mole of atom is. Now, there are two things that you must always mention when we are speaking of 1 mole of an atom, and that is 12 grams of carbon-12. Everything, the mass exactly of 12 grams of carbon-12 must be mentioned in your definition or in trying to define what 1 mole of an atom is. So that leaves us with this only option here, which is the closest option to what the actual definition of 1 mole is, right? So the quantity of 1 mole of atoms of an element refers to the mass of the element, which combines completely with 12 grams of carbon-12 units. So the answer to question 8 is D, as in dog. Right, and this is so because the mass exactly of 12 grams of carbon-12, there's exactly 1 mole of carbon, or 6.02 by 10 to the 23 atoms of carbon-12 in a pile that contains carbon. So for each one of them, you have exactly 12 grams of carbon-12. Right, now the reason why they say carbon-12, because you could have an isotope of carbon, you could have radioactive carbon, carbon-13, carbon-14. So they're referring to carbon-12 as it exists in nature, right? That's what they're referring to. So your answer to this question is D, as in dog, the element which combines completely with 12 grams of carbon-12. All right, question 9. Which of the following substances does not have a giant structure? So let's take a look at these structures. First, we have copper. Copper is a metal, so copper would most likely have a metallic structure. Copper would have a giant metallic structure, right? Graphite is made of carbon, so graphite would have a giant covalent structure, right? Oxygen most times exists as a molecule, O2 gas, right? You might have O2 gas, or you might have O3 as ozone, right? But oxygen is there is a covalent bond existing between one oxygen and another oxygen, but it's a simple molecule. So you have simple molecular bonds in oxygen. And sodium chloride, sodium is a metal, while chlorine is a non-metal. So this here is exhibiting ionic bonding. So we have giant ionic bonding. Right, so the only one that is not a giant structure would be the oxygen, right? Because oxygen have simple molecular structures. So yeah, so I try to get something that could represent it. So between the oxygen molecule, one and the other, there's a strong bond. It's difficult to separate them. But between one molecule and another molecule of oxygen, this interaction here, this bond that binds them together, is a weak bond, right? And this bond can be easily broken. So diamond and graphite, they are made of carbon and they have giant structures. The sodium chloride is a crystal lattice. This also have a giant ionic structure. And copper is metal. It can have a metallic structure, where you have the copper ions is embedded in a sea of electrons that surrounds it, right? And again, this would produce a giant structure. So surrounding the metals, right, you'd have electrons all around, mobile electrons. And it's because of this that metals are able to conduct electricity. All right, so with that in mind, we consider the different types of bonding we have. We have ionic bonding, and this is a giant structure. We have covalent. It could be either a simple covalent bond or a giant covalent bond. Here we have graphite being giant covalent, right? But the oxygen falls under simple covalent bonding. And then we have the metallic structure, which is also giant covalent. Sorry, giant molecular structure, right? So the metallic structure is a giant metallic structure, while oxygen is a simple covalent structure. So with that in mind, coming back to the question they asked us, which of the following substances does not have a giant structure? And our answer to this one is C. Oxygen does not have a giant molecular structure. It has a simple, small molecular structure. Question 10. Which of the following statements best describes the formation of a metallic bond? All right, so when we talk about a metallic bond, I would have hinted something to the metallic bond just now when I was speaking about copper, but we'll go through it here. A metallic bond is formed, we have A when an anion are held together by negative electrons, when metal atoms are held together by molecular forces, when cations are held together by a sea of mobile electrons, when positive metal ions are held together by a sea of anions. All right, so just to recollect, we have cations and we have anions. Right? So with our cations are your positive ions, and your anions are your negative ions. All right? With that in mind, I was speaking to you just now about the metallic bonding, and I was saying that the positive ions are surrounded by a sea of delocalized electrons. So there are the dots in the middle represents the delocalized electrons. Delocalized means it's not in its position, so it is able to move around, it's mobile. Right? So those delocalized electrons are able to move about. So we have a rigid structure that is held in place by these delocalized electrons. So the cations, which are your positive ions, right? The positive ions are your cations. They are held together by these mobile electrons that are able to move about. So these electrons that are able to move about hold the cations, which are your positive charges. So in the previous question, it would have been copper, Cu2 plus inside of here. So in this structure, the metal ion, the metal is inside of here, while the electrons are surrounding it. So with that in mind, let's go back to the question. So a metallic bond is formed when cations, positive ions, are held together by a sea of mobile electrons. And this would be your answer, C as in cat. All right, 11. From which of the following substances can a solid be obtained by the process of sedimentation? From which of the following substances can a solid be obtained by the process of sedimentation? All right, so when we talk about sediments, we are talking about something that has the ability to settle to the bottom, right? Sediments or sedimentation is where something is able to settle at the bottom of something. So when we have gels, just think logically speaking, your gels generally don't have sediments in it. If you have foam, foam again does not have sediments in it. Emulsions don't have sediments in it. So that leaves us with this option, which is most likely suspensions. So A, B, and C don't have sediments in it, but D most likely has sediments. So sedimentation, if something is, you take some dirt and you mix it in some water, the dirt is able to make the water cloudy, but if you leave the water to settle over time, after a while, all the dirt settles to the bottom, which would now be the sediments, and the water would remain at the top, right? So particles are able to become suspended in water, but over time, these particles can settle to the bottom, right? And what the particles that settle to the bottom are referred to as sediments. Inside of a suspension, you can have sediments, okay? So our answer to this question would be D as in dog, suspensions. Question 12. The mass concentration of potassium chloride solution is 60 grams per dm cube. What is the mass of potassium chloride in 25 centimeters cube of this solution? All right, so we're trying to find out the mass of potassium chloride that is in here. So before we are able to do this, we have to first figure out that 60 grams per dm cube. When we're talking dm cube, 1 dm cube has 1,000 centimeters. But we did not asking you for 1,000 centimeters. They're only asking you for 25 centimeters cube, right? So in order for us to figure this out, what we would do, we take the 60 and put it over 1,000 and then multiply that by the volume that they want to give us, right? So the 60 over 1,000 by 25 would give us our answer. Why am I putting over 1,000? It's dm to the minus 3. So it's the same as saying this. 1 over A is the same as A to the minus 1. So if I have 60 grams dm to the minus 3, right? The minus 3 tells us that we're dealing with 1,000. So 60 would be the same as 60 grams over dm. So this is the same as grams over dm cube or grams dm to the minus 3, right? 1 over A is the same as A to the minus 1. So grams over dm cube is the same as grams dm to the minus 3. Just like how this became A to the minus 1, this became dm to the minus 3. All right? So in essence, now that's just a little bit of mathematics. I'm just trying to tell you why this 1,000 is below here. All right? Another way you could have looked at it, you could have taken the 60 and simply multiply it by the 25 over 1,000. Because you want to find out how much is 25 centimeters and not 1,000 centimeters. So you find out what is 25 over 1,000 and then multiply that by 60, you'll get the same answer if you were to work it out. So let me work that and see what we get when we work it out. That by 25. So naught cancels naught. 25 into 25, 1, 25 into 100, 4, 2 into 4, 2, 2 into 6, 3, and half of 3 is 1.5. So our answer is most likely 1.5 grams. All right, 1.5 grams is our answer. Our answer is C as in cat. So in essence, I'm saying to you that they gave us some information, and then we use the information to find what they're asking us. They're asking us what is the mass of potassium chloride in 25 cm cube. We take the information that we know. We know that 1 dm cube is 1,000 centimeters. And then what did they give us? They gave us 60 grams. So it's supposed to have 1,000 centimeters cube in 60 grams. But we do not want to find for 1,000. We only want to find in 25 cm cube. So we take the 60 divided by 1,000 and multiply that by 25, and that will give us our answer. Question 30. Separation of mixtures is based on specific properties of the components in the mixture. Which of the following properties is used to separate a mixture of oil and water? Now, the first thing we have to know, think logically, Last time we heard about an oil spill in the ocean. If you was to check, you would realize that the oil is on top of the water while the water is below. But because the ocean is constantly moving, there will be lipid droplets or oil droplets in between the water because the water is constantly moving. But if if the ocean was able to settle, all the oil would rise to the top and all the water would remain to the bottom. Because water and oil are immiscible, they don't mix together. So even if you were to mix it up, if you leave it to stand, they would separate, right? One is more dense than the other, so therefore water sinks to the bottom while oil would remain to the top. All right, that's why the health officials are able to take, when they're passing around by a place, they could take some oil and they could put a layer of oil, some oil in your water so that the oil covers the top of the water and it would prevent any mosquito from coming and laying eggs in your water, and you end up with a problem where you have breeding mosquitoes inside of open pans of water. Right? Because the oil would form a layer on top of the water, thereby preventing any mosquito from coming and laying eggs. What does that have to do with what we are doing? Here, when we look at the different options, first they have solubility. Right now, when we talk about solubility, the word soluble means has the ability to dissolve. When we talk about something being soluble, we are talking about its ability to dissolve. Right? So the question is, can water and oil dissolve one into the other? Right? And the answer is no. They don't dissolve into the one into the other. So we have to try and figure out which of these options is most viable for us. And then the next option is viscosity, right? We have viscosity. And when we consider what viscosity is, right, is how thick or how thin something is, right? The consistency of the substance. Now, water and oil don't have the same viscosity. So we cannot try to apply viscosity to water and oil. They don't have the same resistance flow. They don't have the same force per unit area. So they don't have the same viscosity. In terms of particle size, we cannot strain water and oil. We cannot take it and put it in a filter paper and try to see if water would separate from oil that way. That wouldn't make sense, right? So that the next option is the boiling point. We cannot boil out the oil from the water. So the option that seems most viable is to take the oil and the water, allow them to settle in something like a separating funnel. And then when they separate, you could run off the water, collect it in one container, and then run off the oil and connect it in a second container, right? So solubility is the most viable answer. The answer is A as in apple, solubility. Question 40. Which of the following separation techniques is not used during the extraction of sucrose from sugar cane? Which of the following separation techniques is not used during the extraction of sucrose from sugar cane? Now, thinking back to when slavery days were happening, one of the most viable food samples or substances or crops that they used to grow at that time was sugarcane, right? And sugarcane was exported after it was cut down and whatever not, and they would process it and then take it and they would make money from selling the sugar. But the process of getting the sugar, first you have to cut it down, take it and transport it to the factory. Then when it reaches by the factory, it has a whole that mud, dirt, and all of that on it. The first thing they would need to do is they would need to clean the sugar cane. So you need to wash and clean the sugar cane. After you do that, how they would do that, they would spray jets of hot water onto the sugar cane, right? So by doing that, they're getting rid of all the mud and the dirt and whatever else is on the sugar cane so that they can now start the process. At this point now, they begin to crush it, just like how you would do if you were eating sugar cane. You would take your teeth and you would crush up the sugar and suck the juice as it comes out of the sugar cane. So what they do, they crush the sugar cane, and the fibers that are produced are referred to as the bagasse. So the bagasse is used later on in the process as a source of fuel, but the juice that comes out of it, it undergoes a purification process. So you now have the juice extraction and you have to get raw juice, and this juice needs to be purified, right? In that process, you would have filtration taking place. So you need to have a filter, right? So you have to filter out all the impurities in order for us to get that raw juice. Now, the next thing that needs to happen, we need to clarify the juice. And this process of clarification and heating involves precipitation, right? The formation of a solid. Now, when we have precipitation taking place, the next thing, because we want to get the sugar from the sugar cane. So the next thing we have to do, there was excess water at the start of the process. We need to allow a lot of the water to evaporate. So that next process that undergoes is a process of evaporation, where you leave the sugar and the excess water in it to simmer down by allowing all the excess water inside of it to evaporate, right? When it becomes concentrated, the next thing they're going to do with it now, they're going to take it and put it into a centrifuge. Now, the centrifuge is basically apparatus that has the ability to spin at high speeds, right? It spins at high speeds round and round and round. And it have pores inside of the container that separates molasses from the sugar, right? So molasses, one is able to come out while the other remains inside, and then they can bottle the molasses, they could bag the sugar, and then they can sell both of them. So nowhere in this process is chromatography involved. All of that is to tell you that simple line, that nowhere in that process it involves paper chromatography. Right? So the answer is D, as in dog. Chromatography is not a part of that process. All right, question 15. Barium is below, and then something like that in history. Okay, cool, cool. Yes, it is part of history actually. It is. They just from a small extent tie it back into chemistry, but it definitely has to do with your history. Absolutely right. Question 15. Barium is below calcium in group 2 of the periodic table. When these metals react with water, the main differences in observation is, now with this question, the first thing you have to recognize is that barium is below calcium and they are in the same group. Elements in the same group behave the same way. So they will give off a similar reaction. They would give off a similar color change. They would give off the same gas. They would behave the same way with litmus paper, with universal paper. Because they are in the same group, they would behave similar. So we're looking for something that is not similar, but that would be different for them all. So the gas evolve would be similar. So it wouldn't be the gas evolve. The rate of the reaction. When we go down the group, the number of shells increases. So the distance of that electron from the outermost shell, the nucleus distance from the outermost shell is getting further and further away as you go down the group, right? The distance, the electron in the outermost shell is further away from the nucleus. So for a reaction to take place, it becomes easier and easier to lose an electron as you go down the group. So the rate of the reaction would be different for barium in comparison to calcium, right? Because barium is below calcium. So calcium would be more reactive than barium because calcium is higher up in the group than barium, which is lower down. So barium will take a longer time to react than calcium with another element, right? Color of the product, they would produce similar colors. Color change with litmus paper, they would have a similar color change with litmus paper. Gas evolve, similar gases would evolve, but only the rate of the reaction would be different. So our answer to this question, B as in boy. All right, 16. Graphite can be used as a lubricant because of the, all right, so we go in here, graphite being used as a lubricant. Now, in vehicles, we want to use lubricants. And for vehicles, we use oil. So you'll have car oil and you use it as a lubricant to ensure that the engine doesn't seize up and lock up. If you have a bicycle, you take some grease and you put it between the axle of the wheel so that the bicycle, the axle doesn't rust and the bicycle can ride smoothly. So lubricants, we need lubricants. And they're saying graphite can be used as a lubricant. Now, graphite has a macromolecular structure. It's very sturdy and strong and hard. But graphite in its molten state can act as a lubricant, molten or liquefied state. And this is because the layers in graphite are able to slide over each other. And that slippery nature of graphite allows it to be able to act as a lubricant, right? So due to its loose, intact carbons, or the free electrons that are present, they are able to move around easily from one place to another. And this makes graphite a good conductor of electricity in its molten state or in its liquefied state. So the loose electrons, which can move throughout the lattice, would make graphite a great lubricant because it's able to move. It has a slippery nature, and the loose or the free or the mobile electrons that are present in the structure allows it to move freely. So our answer to this question is A as in apple, loose electrons which can move throughout the lattice. A as in apple. All right, question 17. Which of the following halogens is a liquid at room temperature? Which of the following halogens is a liquid at room temperature? All right, so let's look at them first. We have bromine, fluorine, chlorine, iodine. So we are dealing with halogens. These elements are all in group 7. So we know that they're all missing 1 electrons to become completely filled. Okay, fair enough. So let's take a look at some of the properties of halogens. As we go down the group, it goes from yellow to green to orange to gray, black to black. So it's getting darker and darker. All right. The state, it's going from gas, fluorine, chlorine as a gas, bromine as a liquid, iodine as a solid, astatine as a solid. So it goes from gas to liquid to solid. And here, bromine is a liquid at room temperature. Right? And then you can look at the others, increase in molecular size, increase in density, increase in activity. But we're not interested in all of that. We're just looking at the state. And bromine is a liquid at room temperature. So with that in mind, let us come back to the question. The question asks us, bromine, what is bromine? And well, which of them is going to be a liquid at room temperature? At room temperature, we're going to have A as an apple. The answer is going to be bromine is going to be a liquid at room temperature. All right, so question 17, the answer is A as in apple. Bromine is a liquid at room temperature. All right, astatine is another element. It's another halogen, but it normally exists as a black. You normally see it as a black rock. But it's one of the rarest elements on Earth. Yes, you're correct in that aspect. I'm not sure of its uses, but it's very unreactive because at room temperature and pressure, it tends to be in its solid state. So it's difficult to react. It's easier to react with halogens that are higher up in the group, but astatine is also a halogen. But just at this level, we don't talk about it much in terms of it being reactive or reacting with elements. It doesn't react that much. Right, the other halogens, which is the fluorine, the bromine, the iodine, they are more reactive than astatine. All right. So question 18. Which of the following terms best describe strong acids? Which of the following terms best describes strong acids? Now, when we talk about strong acids and weak acids, we are not talking about its concentration, right? When we speak of strong acids and weak acids, we are not referring to its concentration, because I could have a weak acid, right? And it could be concentrated. And I could have a strong acid and it could be diluted. So we are not talking about the concentration of the acid when we refer to strong acids and weak acids. When I'm talking about strong acids, I am talking about the number of H plus ions that are able to completely dissociate from the compound that it's in, right? It's able to separate completely. So strong acids, for example, if I have hydrochloric acid, HCl, the ability for HCl to give me H plus ions and Cl minus ions, the ability for this to happen, where all the H plus, the hydrogen here becomes H plus ions completely, then hydrochloric acid would be a strong acid. But if all the hydrogens that are present are not able to give me H plus ions from the compound that it's in, then I would end up with a weak acid. Means to say I will have partial dissociation. The word dissociate means to separate into its parts. So I will not have complete dissociation. So therefore I'll be dealing with a weak acid. Strong acids tend to completely dissociate or completely separate into its ions. So if I had something like H2SO4, and all the H plus ions are not able, well, all the hydrogen are not able to become H plus ions, then I can be dealing with a weak acid. But sulfuric acid, all the H plus ions completely separate. So sulfuric acid again is another strong acid. So if I had something like ethanoic acid, CH3C double bond OH, that structure, not all the H plus ions are converted from atoms to ions. So you're referring to a weak acid if we were talking about sulfuric acid, hemisulfuric, the ethanoic acid. So coming back to the question, which of the following terms best describe strong acids? Not concentrated. Partially ionized refers to weak acids. Concentrated and partially ionized again refers to weak acids. The most correct answer, and they ask for the best one, is the one that is ionized to a large extent. So it's ionized like 80% or 85% or 90% ionized, right? You're most likely dealing with a strong acid. So just to recap what strong acids and weak acids are. When we speak of strong acids and weak acids, strong acids, they do not, they completely dissociate, while weak acids do not completely dissociate. Examples of strong acids, some are listed here for you. You have nitric acid, hydrochloric acid, hypochlorite, sulfuric acid, and so on. Some examples of strong acids. So the most correct answer from the option that they give us is C as in cat. C is the most correct answer from all of our answers that we have. It's ionized to a large extent, and that is our best answer, right? It's not the exact definition of what would help identify strong acids. If they had said strong acids completely ionized, then that would have been the perfect answer. But here they say it ionized to a large extent, and so therefore this is the closest answer to what is correct, right? If you come across a question in exam and it don't have the correct answer, you look for the next answer that is closest to the correct one, and that answer would be your answer. All right, question 19. Moving along. A solution has a pH of 1. So right away, just from this information alone, you know that you're dealing with an acid because it has a pH of 1. Something with a pH of 1 is very acidic. Why is that? You have a number line, you have a pH scale. 7 is neutral, 14 is basic, and 1. So this range here, 1 to just before 7 is acidic. After 7 to 14 is basic, and 7 is neutral. All right, so we're dealing with something that is 1, so we're dealing with something that is very acidic. Okay, fair enough. So this solution would be expected to react with, so what do we know about acids? Acid plus a base give you salt and water. Acid plus a metal supposed to give you a salt and hydrogen gas. All right, so we know that much. Acid plus a carbonate, well, they have nothing with a carbonate in it there. So, all right, so let's check that alone. So the first one, A, zinc metal to produce hydrogen. Yes, that will happen. An acid plus a metal gives you hydrogen gas. So A looks like a correct one. Let's check B. Acid plus a metal to produce a pH of 10, that will make sense. The acid with a metal, it's a produce a salt, not a base. Acid plus a metal doesn't produce a base. Something with pH 10 is a base. Acid plus a metal doesn't produce a base, it produces a salt. So B is incorrect. Acid plus hydrochloric acid, you wouldn't add an acid to acid, that doesn't make sense at all, to produce chlorine. You wouldn't add an acid to acid. Acid plus hydrochloric acid to produce a salt and water. No, an acid plus a base gives you salt and water, not an acid plus an acid. That don't make sense either. So that leaves us with the option A, as in apple, as our most correct answer. Right? A as in apple seems to be our most correct answer. So acid plus a metal gives you a salt and hydrogen gas. All right. Question 20. Question 20 refers to 1 mole of each of the following acids. You have H2SO4, which is sulfuric acid. You have CH3COOH, which is your ethanoic acid. And you have COOH2, that is a diacid. All right, diacid because I have 2 COOH functional groups. All right, that's all it's saying. COOH here bonded to another COOOH. Right? This is one acid group, and this here is your second acid group, and both of them together gives you a diacid. Right? 1 is mono, 2 is di, 3 is tri. Because I have 2 of the acid groups, I have a diacid. Okay, no problem. So they tell you which of the above acids would require more than 1 mole of sodium hydroxide for complete neutralization. Which one would require more than 1 mole of sodium hydroxide for complete neutralization? So let's take a look at the options that are placed before us before we look at the answers that we have. So if I were to react H2SO4 with sodium hydroxide, the sodium is going to replace the hydrogen, and I will end up with sodium sulfate, NaSO4, right, Na2SO4 plus water. All right, now it requires 2 moles of NaOH to react with 1 mole of H2SO4, right? You need a 2-to-1 ratio for this to happen. So this one requires 2 moles. So something with the answer 1 in it should be correct. We look at the second one. We have ethanoic acid. All right. So you have CH3COH plus NaOH. Again, the hydrogen in the ethanoic acid is replaced with the sodium, so I'll end up with CH3COONA instead of H plus H2O, right? So the sodium is replaced by hydrogen, and the hydrogen that was here comes and binds with the OH to give you water. The hydrogen that's here comes and binds with the OH to give you water. So each time it's binding with the OH to give you water. All right, but in this second one, only 1 mole of the ethanoic acid is required with 1 mole of NaOH. So anything that have 2 in it is not our answer. And then we're looking at the third one. You have COOH2. If this is times 2, then for each one of the structures, for C, double bond O, OH, again, the hydrogen is going to be replaced by sodium, right? hydrogen is going to be replaced by sodium. But the thing is, we have two of these structures. So we need this process to happen times 2. And they ask which one which one of the above would require more than 1 mole of NaOH. So the third one would require more than 1 mole of NaOH. And the first one would require more than 1 mole of NaOH. So 1 and 3 is supposed to be our answer. C is wrong. The answer should be B as in boy. Right? 1 and 3 is our answer. The answer is B as in boy, not C as in cat. B as in boy is our answer. Right? H2SO4 and the diacid, the COOH2, they both would require more than 1 mole of NaOH to have complete neutralization. Right? So our answer to this one is B as in boy, 1 and 3, and not C as in cat. Right? The answer is B as in boy, 1 and 3, and not C, 2 and 3. All right, question 21. Which of the following terms best describes the oxide of a metal? All right, so this question here is a tricky question. And the reason why, naturally speaking, as we talk, when we talk in science and chemistry and stuff, sometimes people interchange a base and an alkali. And in this question, they have base as an answer and alkali as an answer. And we have to figure out which of these answers is correct. So which of the following best describes the oxide of a metal? Now, the oxide of a metal means to say that we are dealing with a basic oxide, right? When we have a metal and that has an oxygen attached to it, that's all an oxide is. An oxide is a substance, whatever the substance is, that have oxygen attached to it. And that substance become an oxide. So the oxide of a metal is simply a metal that has oxygen attached to it. It becomes a metal oxide. So for example, magnesium with oxygen, it would be MgO, magnesium oxide. Copper with oxygen, it will be CuO, copper oxide, and so on. So which one best describes the oxide of a metal? It is a basic oxide. So the question is B the answer or is C the answer? Right? Because base and alkali, they refer to something similar in our minds. So let's take a track back before we answer the question completely. A base is a substance that neutralizes an acid. An alkali is a soluble base, right? So all alkalis are bases, but not all bases are alkali. I'm running that back. A base could neutralize an acid, and all alkalis are soluble bases. The word soluble means it can dissolve. If we have an alkali that cannot dissolve, then it's not an alkali. We are dealing with a base. So all alkalis are bases, but not all bases are alkalis. Right? All alkalis are bases, but not all bases are alkalis. Because alkalis are soluble in water, but bases, some bases are not soluble in water. Right? So in other words, alkalis are those bases which could dissolve in water. All right? So a base is a substance that basically reacts with an acid and is able to neutralize them. Bases, you could have metal oxides, example, copper oxide, metal hydroxides, sodium hydroxide, metal carbonates, calcium carbonate, and so on. But many bases are insoluble, which means to say that they do not dissolve in solution. However, if a base does dissolve in water, we now call that base an alkali, right? So an alkali is a base that could dissolve in water. All right, so coming back to the question. Which of the following terms best describe the oxide of a metal? A base describes the oxide of a metal because not all metal oxides dissolve in water. All right, so if you said alkali was the answer, you would have gotten it wrong. But if you said base is the answer, then you'd have gotten it correct. Right, because an alkali is a base, but a base don't necessarily have to be an alkali. All right, so I hope I didn't confuse anybody there. All right, question 22. A solution, when reacted with the gas sulfur dioxide, becomes green. So some solution, when reacted with sulfur dioxide, that solution becomes green. The solution contains potassium dichromate. The answer to this one is C as in cat. That solution becomes potassium dichromate. Now, the chemical reaction between sulfur dioxide gas and acidified potassium dichromate results in the characteristic color of the potassium dichromate changing from orange to green, because potassium dichromate, naturally speaking, has an orange color, and it can go from orange to yellow, yellow to orange if you're reacting it with the acid or base. But if you react it with the sulfur dioxide, it will go from the orange to green. Why not potassium permanganate? Potassium permanganate is purple in color. So potassium permanganate will go from purple to colorless, right? It will go from purple to colorless and not orange to green, right? Acidified potassium permanganate, or manganate 7 as they refer to it, goes from purple to colorless. And with acidified potassium dichromate, it will go from orange to green. All right, so the answer to our question, which solution, which when reacted with sulfur dioxide gas, it becomes green, the solution contains potassium dichromate, because the dichromate ion is originally orange and it goes from orange to green. It will not be the nitrate, it will not be the sulfate. Our options would have either be C or D, either the dichromate or the potassium permanganate. One out of the two. The potassium permanganate goes from purple to colorless, which is not green, while the dichromate goes from orange to green, which is the color that we are looking for. So our answer is C as in cat. All right, 23. In the electrolysis of aqueous copper 2 sulfate solution using copper electrodes, the anode, so let's take that in mind. You have copper electrodes. Right, in some solution. And you would have an anode and a cathode, right? So at the anode, it attracts anions, and the cathode attracts cations, right? So the anode attracts anions and the cathode attracts cations. The cathode attracts positive ions, which are cations. So the cathode is negatively charged, right? The cathode attracts positive ions, so the cathode is negatively charged. So they're telling you, in the electrolysis of aqueous copper 2 sulfate solution using copper electrodes, so these electrodes are made of copper. This is made of copper. The anode attracts anions. Anions are negative ions. So the anion is the positively charged ion. The positively charged ion in aqueous copper 2 sulfate, you have copper ions, Cu2 plus, and you have sulfate ions, SO4 2 minus. Right? With the Cu2 plus, which is your positive ions, they are going to be attracted to the negative electrode, the cathode. But the electrode itself is made of copper. So in order for the copper ions to move from this one to the next electrode, the copper needs to come out of the electrode and go across. So it is going to decrease in mass. That electrode is going to decrease in mass at your anode. Right? The anode is going to decrease in mass because the copper ions inside of that anode is going to move across to the cathode. Right? Thereby giving you pure copper, or you can copper plate something. All right, electroplating, you can call that that process if you plate something with copper. So to answer the question, what is going to happen is that ionization is going to take place. So the copper is going to become ionized. It means it becomes an ion, and in the process, the mass of the electrode is going to decrease. So it is going to decrease in mass, and eventually you'll have to replace the electrode. So the answer is A, as in apple. Okay, so question 24. The equation for the reaction of silicon with chlorine is as follows, and they give you Si in solid state plus 2 chlorine gas to give you silicon 4 chloride, so silicon tetrachloride. All right. In this reaction, silicon is the reducing agent and is, so if silicon is the reducing agent is itself oxidized. So the answer could either be A or B. Silicon is the reducing agent. The reducing agent is itself oxidized. So we're checking to see whether it is with an increase in oxidation number or a decrease in oxidation number. Silicon here has no oxidation number, but silicon on this side is going to have an oxidation number of +4. The reason why it's going to be +4 is because chlorine is -1, and -1 multiplied by 4 is -4. So to balance it off, you need silicon to be +4 for this compound to balance and equal to 0. All right, so it has an increase in the oxidation number. So it went from silicon being 0 here, it has no charge on it, to being silicon +4, right? Because it's now bonded to chlorine, which is -1. And we have 4 chlorine atoms present. So the answer to this question should be A, as in apple. It is oxidized with an increase in the oxidation state. The answer to the question is A, as in apple. All right, 25. Which of the statements below is true for the following equation? You have magnesium in its solid state plus H2SO4, which is sulfuric acid, to give you magnesium sulfate, MgSO4, plus hydrogen gas. So they ask me what is going to be happening from the math in this equation. Which of the statements that they have there, which of them is true? So, okay, let's go through the statements and see which one is correct and which one is false. So magnesium here has no charge. Magnesium is 0. But on this side here, oxygen is -2. So this is 4 2s are 8. Sulfur would be +6, and magnesium here would be +2. So magnesium went from being 0 to being +2. And okay, so magnesium is oxidized. If it went from 0 to +2, magnesium is oxidized. Oxidation, OIL. Oxidation is the loss in electrons or gain in oxygen, right? If magnesium went from having no charge, from 0, and it is now +2, if you lose 1 electron, it becomes +1. If you lose a second electron, it becomes +2. So magnesium lost 2 electrons. Oxidation is the loss in electrons, right? So magnesium was oxidized, and the oxidation state went from 0 on this side here, having no charge, to being +2, being bonded to something. All right, so magnesium went from 0 to +2. You say, sir, but if I didn't know how to figure out how it's +2, look at the question and see what is the answers that they give you below. In the answers below, the options that they have is +2, 0, 0 +2, +2, 0, and then 0 +1. So the question is, which of these things are correct, right? So hydrogen, if you were to look at hydrogen, again, sulfuric acid here, you have S is +6, hydrogen is +1, and this is 1 by 2 is 2, oxygen is -2, 2 4s are -8, sulfur is 6, hydrogen is +1 by 2 is 2, so 6 + 2 is 8, -4 2s are 8. On this side here, hydrogen is 0. So hydrogen went from being +1 to being 0. Here they say hydrogen is oxidized from state 0 to +1. This is the reverse. It went from being 1 on this side to having no charge on this side, because hydrogen by itself exists as a gas, and as a gas it exists as a diatomic molecule. So I have hydrogen gas H2 and it has no charge on it, so it is 0. So the answer to this question is B as in boy. Magnesium is oxidized from oxidation state 0 to +2. All right, so if the number was the reverse here, then we could have considered D as an option to consider, right? But it's not. So our only answer is B as in boy. All right, question 26. 2.32 grams of an oxide of iron were heated in dry hydrogen. When the reaction was completed, 1.68 grams of iron were formed. They give us the RAM. Iron Fe is 56 and oxygen is 16. All right. The oxide of iron, Fe2O3, was, so if you look at the equation, we react the oxide of the iron, Fe2O3, with hydrogen, and it will give us this equation. Iron as a solid plus water vapor, right? The iron oxide, or the oxide of iron, Fe2O3, would give us iron as a solid here and water vapor, water as a gas. So they're asking you what is happening to the oxide of iron. Iron, Fe, has lost oxygen. Right? Iron has lost oxygen. So RIG, right? Reduction is the gain in electrons or the loss in oxygen. So iron oxide has been reduced because it has lost oxygen. So it went from being iron oxide to being iron. So there are some metal oxides that would react with hydrogen and are reduced by the hydrogen, while there are other oxides that when they react with hydrogen, they are not reduced by the hydrogen, right? So iron oxide, lead oxide, copper oxide, and silver oxide are all reduced by hydrogen. All right, so our answer to this question is A as in apple. The oxide of iron was reduced. All right. Acidified potassium manganate 7 is, they have reducing agent, oxidizing agent, a dehydrating agent, both an oxidizing agent and reducing agent. All right, so let's see. A reducing agent, it loses electrons, but is itself oxidized. An oxidizing agent, it gains electrons, but is itself reduced. Okay, that much we know. An oxidizing agent causes oxidation, yes, while a reducing agent causes reduction. Okay, yes. So examples of oxidizing agents and reducing agents, a list has been provided for you. And acidified potassium manganate is a oxidizing agent, right? Just so you know, potassium manganate is a oxidizing agent. So the answer is B as in boy. All right, question 28. During the electrolysis of aqueous copper 2 sulfate solution using inert electrodes, the ions migrating to the cathode are, so you have aqueous copper 2, we have aqueous copper 2 sulfate solution. So we have the cathode and we have the anode. Right? At the cathode, we have cations, which are positive ions. And at the anode, we have negative ions. So we have aqueous copper 2 sulfate. So we have copper sulfate, CuSO4, dissolved in solution. So we're going to have copper ion, sulfate ions, but it's aqueous, so that means it's dissolved in water. If we have water, we have H plus ions, and we have OH minus ions. So copper is 2 plus, and SO4 is 2 minus. So which ions are going to migrate to the cathode? The positive ions, which are your cations, which would be H plus and Cu2 plus. Cu2 plus and H plus. So answer is most likely D as in dog. Those ions would migrate towards the cathode. All right, question 29 and 30 refers to the following option. Each option may be used once, more than once, or not at all to answer the items below. We have iron, lead, copper, and magnesium. Which element, 29, forms an oxide which cannot be reduced by hydrogen? So we're looking for an element that is below hydrogen in the reactivity series. So if we were to consider the reactivity series, iron is above hydrogen in the reactivity series, lead is above hydrogen in the reactivity series, and magnesium, again, is above hydrogen in the reactivity series. That leaves us with copper, which is below hydrogen in the reactivity series. So the answer to 29 is C. Copper cannot reduce the hydrogen because copper is below hydrogen in the reactivity series. And elements that are higher up in the reactivity series are given preference to those that are lower down in the reactivity series. Copper is higher up, so therefore copper is preferred. Sorry, copper is lower down, so therefore hydrogen is preferred over the copper, right? Copper is below hydrogen, so hydrogen is preferred over the copper. So therefore copper cannot reduce hydrogen. The answer to 29 is C as in cat. So which element would be liberated from an aqueous solution of its salts during electrolysis? This is most likely, again, if you check the last two questions that we did, they had the aqueous solution of copper sulfate. So most likely copper, again, copper ions would be liberated from an aqueous solution of its salts during electrolysis. Again, copper is your answer, C as in cat. So for question 30 and 29, the answer is copper, C as in cat. Question 31. Which of the following statements about electrolysis is not correct? So what is electrolysis? Again, if you split the word up, you have electrolysis. Lysis is the split, and electro is using electricity. So using an electric current or using electricity to split a compound into its ions and its elements. All right, so which of the following statements about electrolysis is not? It is not correct. Which one is not correct? All right, so the electrons leave the solution via the positive electrode. Yes, that is correct. Electrons enter solution via the negative electrode. Yes, that is correct. Anytime you have a circuit, electrons always move out of positive into negative. So number one, and A and B is correct. Part C, decomposition of the electrode at the electrolyte produces an electric current. This is not correct. It does not produce an electric current. The decomposition or the breakdown of the electrolyte does not produce an electric current, right? It's the presence of those mobile electrons which allows the ions are free to move around. The free ions are able to produce an electric current, right? Decomposition of the electrolytes at the electrode is due to an electric current. Yes, it is due to an electric current, but it is not produce, or it does not produce an electric current. An electric current passes through it and causes it to separate. So the answer is not D, the answer is C as in cat. This one is wrong, right? The decomposition of the electrolyte does not produce an electric current. So C is the one that is incorrect. All right, question 32. How many coulombs of electricity passes through an electrolyte when a current of 100 amp flows for 10 minutes? Now there's a formula. When you want to calculate charge, Q is equal to IT, right? Where I is the current in amperes and T is your time in seconds. So first thing we need to check, we have 10 minutes, so we need to first convert minutes to seconds, and we have 100 amperes. So to convert minutes to seconds, that's 10 by 60, because you have 60 seconds in 1 minute, and this would give us 600. And then we have 100 amperes. So we know the time is 60 seconds, and we need to multiply that by the current, which is I, and the current is 100. So we multiply 100 by 600, and our answer is supposed to be 60,000. Right? So they say, what? How many coulombs? So it's supposed to be 60,000. C, 60,000 coulombs. Right? So that's the charge. The answer should be D as in dog, 60,000 coulombs. All right. Question 33. The rate of a chemical reaction does not depend on, so let's see again, the active word here is not. Not. Does not depend on, so let's start with the first one. The presence of a catalyst. A catalyst does alter the rate of a reaction. So the rate of a reaction depends on a catalyst, yes. The concentration of the reactants. The more reactants we have, the faster the reaction could take place and the longer the reaction could run for. So yes, the concentration of the reactants will determine how fast the reaction take place. Okay. The energy change of the overall reaction. Now, energy can neither be created nor destroyed. It's just simply transferred from one form to the other. That's the law of conservation. So this one here, it does not, the energy change of the overall reaction does not affect the rate of the reaction, right? Reactants being converted to products, or reactants being converted to products, whether we have an endothermic or exothermic reaction, either way, all the reactants is going to become products, or all reactants are going to become products, no matter whether it's an endothermic or exothermic reaction. So the energy change of the overall reaction does not affect the rate of the reaction, right? So the rate of the reaction is not affected by the amount of energy change that is required to convert reactants to products. So C seems to be the odd one out thus far. Temperature of the overall of the reactant system. Yes, if you increase the temperature by 10 degrees Celsius, most times the reaction increases twice as much, right? The temperature of the reaction would cause a spike or change in the rate of the reaction if we increase temperature. So the answer seems to be, or looks to me, as C as in cat, the energy change of the overall reaction. All right, question 34. At a flour mill, there is the risk of an explosive reaction occurring when a match is struck. This is due mainly to, and you have A, B, C, D options. Increased pressure in the area. No, increase in pressure wouldn't most likely increase the risk of an explosion. You're dealing with a flour mill, all right? And your flour is most likely in powdered form. So therefore, it's supposed to have large surface area. Increased concentration of flour. No, increasing the concentration will increase the explosiveness of a reaction taking place, or the risk of an explosive reaction. High temperatures caused by the lighted match. No, the high temperatures by the lighted match. Yes, that is a risk, but that would not be the risk of the explosion. Large surface area be created by a large number of small particles. Because the flour is in powdered form, yes, there are large surface area created by a large number of small particles. So there is the risk of an explosion. So the answer should be D as in dog. Large surface area be created by the large number of small particles. Question 35. Which of the following metals can be extracted by electrolysis? Now, aluminum is extracted by electrolysis. The other elements, they can be extracted using carbon, right? So a blast furnace of some kind can be used to extract carbon. Use carbon to extract zinc or iron from its ore, but aluminum is extracted by electrolysis, right? So the answer to this one is C as in cat. Aluminum is extracted by electrolysis. The other elements would require carbon to be extracted. All right, question 36. When crystals of potassium nitrate are dissolved in water, the temperature of the solution decreases because the energy is required to break down the crystal structure of the potassium nitrate. That is correct. A lot of energy is required to break the bonds before product can be formed. So many of you may say, but sir, it's just potassium nitrate dissolving in water. And that is a reaction. In order for the reaction to take place, it is called the enthalpy of solution. If you decide to go on and do chemistry at the Cape level, dissolving something in water is referred to as the enthalpy of solution. So when crystals of potassium nitrate are dissolved in water and the temperature decreases, a decrease in temperature means we are dealing with most likely some kind of endothermic reaction. So energy is required to break the bonds inside of the potassium nitrate to give you potassium ions and nitrate ions. So your answer is most likely A as in apple. And question 37, which of the following pair of substances is most suitable for producing carbon dioxide? Something with a carbonate in it would make it easy for us to produce carbon dioxide. You have dilute hydrochloric acid and calcium carbonate. This is most likely the option, right? The acid plus the carbonate, the calcium carbonate, right? You'll end up with calcium chloride, carbon dioxide, and water, right? The acid plus a carbonate give you a salt, water, and carbon dioxide gas. Sodium hydroxide, no, it wouldn't be. This one would be the next option, but you wouldn't use the base, you would use the acid. The answer should be A as in apple and not C as in cat. All right, so 36, A as in apple, 37, A as in apple is your answer for them both. All right, 38. 38 and 39 refers to the following sequence of reactions involving ion compounds, where 1, 2, 3, and 4 represents progressive stages in the sequence. All right, so now you see this sequence of equations and you ask yourself, but I never see this thing before. I never do nothing like this in my life. How they expect me to know it? All right, so they're not expecting you to know the reaction. They just look at the question, see what they're asking you, and see if you can figure that out. So in which stage is the oxidation state of iron increased? So we need to find out what is the oxidation number of iron here, there, here, here, and there. How are we going to do that? Oxygen is -2. All right, so this is 3 2s are 6. So therefore, if this is 6, then carbon is most likely +4, and iron here is most likely +2. So Fe in this first state here is in its +2 state. All right, so come over here, oxygen again is -2. So iron here is most likely +2 to balance this off. +2 minus 2 equals 0. So iron is +2. Again, oxygen here, right? Another way you could look at it, the charge on the iron, if it's just these two, becomes the charge on the oxygen, and the charge on the oxygen becomes the charge on the iron, right? You could look at it that way. Or we could do it the other way. You have minus 2, 3 2s are minus 6. So therefore we need plus 3 to get 3 2s are positive 6. So iron has moved from being plus 2 to plus 3. So in this point here, at this point here, is where the change has taken place. So we could go on and look further. Here again, look, the 3 here, the charge here would be now 3, and the charge in this one becomes the charge over here. So Fe is going to be plus 3 and SO4 would be 2 minus, if we were to look at it that way. If we were to actually work it out, again, this would now be minus 2. So 2 3s are minus 6, so therefore we do plus 3 to make this 3 2s are 6 for it to balance out. So Fe is now plus 3. So with that in mind, how does that help us? The question asks, at which stage is the oxidation, at which stage is the oxidation state of iron increase? And that would be at this stage right here, where it went from plus 2 to plus 3. And that would be answer B as in boy, at stage 2. All right. So 39, a suitable reagent that could be used at part 4 is, so they have steam, which is water vapor, H2O. You have hydrogen, then you have solid copper oxide, and you have aqueous sodium hydroxide. So let's see what happened. It went from Fe2SO4, where you have a sulfate, to FeOH3. So you need something that have OH inside of it in order for the iron to be bonded to a OH group. Hydrogen don't have OH, steam is H2O, solid copper oxide, and aqueous sodium hydroxide. Sodium hydroxide is NaOH. So most likely it's the sodium hydroxide that produce the iron hydroxide. So the answer to 39 should be D as in dog. So 38, the answer should be 2. B as in boy, and 39, the answer should be D as in dog, aqueous sodium hydroxide. Okay, question 40. Which of the following metals can displace zinc from a solution of zinc sulfate? Which of the following metals can displace zinc from a solution of zinc sulfate? So we have iron, lead, copper, and aluminum. Okay, so we need something that is above zinc in the reactivity series, and that metal will be able to displace zinc. Iron is below zinc, lead is below zinc, copper is below zinc, aluminum is above zinc. So aluminum would be able to displace zinc, and instead of having zinc sulfate, we will end up with aluminum sulfate. Aluminum could displace zinc, so the answer is D as in dog, aluminum, because it's higher up in the reactivity series, right? So aluminum is higher than zinc in the reactivity series, so therefore aluminum could displace zinc. All right. Question 41 to 42 refers to the properties of 4 metals, W, X, Y, and Z, which are summarized in the following table. So you have metal W, X, Y, and Z. W, there's no reaction. X reacts with steam, but not with cold water. Y reacts with cold water, while Z reacts slowly with cold water. So 41, the order of reactivity of these metals with the most reactive first is, so let's take a look. The most reactive is the one that reacts rapidly. So we're looking for that one, and that one is Y. Y reacts rapidly with cold water. So that's our first one. So we're looking for something that have Y, that gives us option C or D. Y reacts rapidly with cold water. Okay. So then we're looking for the next one, the one that reacts slowly. Z is the one that reacts slowly. So first Y is the first one. Then Z is the second one. Then we're looking at the one that is reacting but not reacting with everything. That's X. X reacts with steam but it doesn't react with cold water. So this one is the third one. And then the fourth one we have W doesn't react at all. So we're looking for YZXW. YZXW. That gives us D as our answer. Y, Z, X, and W. All right. Question 42. Which of these metals form a carbonate which is stable to heat? The one that's most likely reacting rapidly with cold water. This one would most likely form a carbonate here because we have the nitrite and oxygen. So yes, this one is most likely it's going to form the carbonate. This is one of those questions, is either you know this one or you didn't know this one. All right, so it would react, because it's reacting rapidly with cold water, right? It's also able to form a carbonate which is stable to heat. All right, 43. Which of the following substances forms dense white fumes with ammonia gas? Dense white fumes with ammonia gas, that is hydrogen chloride. If you react an acid with ammonia gas, you will get dense white fumes. The answer should be D as in dog. You react an acid with ammonia, you'll get dense white fumes. The answer is D as in dog. Question 44. Which of the following observations is likely when excess aqueous ammonia is added to a solution of copper 2 sulfate and the mixture is shaken? All right, so if we were to first take aqueous ammonia, and that is simply ammonia dissolved in water, right? If you take aqueous ammonia and you were to react it with sodium hydroxide, it's supposed to give you a blue precipitate. And then when you react that with aqueous ammonia, it's supposed to give you a blue solution, right? So they did not put in the first part in this question, but the second part they're saying here, they reacted with aqueous ammonia in excess. So we expect to get a deep blue solution, right? A deep blue solution is what is expected. So anything that is green will not be an answer because copper sulfate is blue in color. So you're expecting to get a deep blue solution. You're not going to get a green solution or a green precipitate. You would either get a deep solution or a light blue precipitate. The light blue precipitate would have been when you add sodium hydroxide, but we did not add sodium hydroxide. All we added was aqueous ammonia, so you're expected to get a deep blue solution. That tells us that the copper 2 ions inside of the copper sulfate dissolve. All right, so we had the formation of a deep blue solution. So the answer should be C as in cat. Question 45. Which of the following molecules could be obtained by cracking the alkane C8H18? When an alkane undergoes cracking, an alkene is produced and a smaller alkane. So anything that has carbons that are less than C8, we could consider. If we have something like C12, not possible. Something like C14, not possible. Something like C16, not possible. Because that means we are taking one carbon and we are producing something that is greater than it, which is not possible. All right, so what is produced is an alkene plus a smaller alkane. So which of the following molecules are possible? C2H4, this is an alkene. So this is possible. CnH2n, that's possible. C6H14, 6 is less than 8, so yes, this is possible. C6H14, this is possible. So 1 is possible, 2 is possible. C16H34, that's not possible. Because you can't start off with 8 carbons and then end up with 16 carbons. right? Unless you have the power of the creator and you could create carbons, that's not possible. So our options are 1 and 2 only. The answer should be B as in boy. 1 and 2 only. Our answer is B as in boy. All right, question 46. Item 46 refers to the following equation, and they give you the equation there. All right, so we have an alkene, because there's a double bond present, reacting with bromine, Br2, which is a halogen, to give you some product X. Okay, so they ask you to say, what is the correct structural formula of X? So if we have bromine, what is going to happen? This carbon right here with double bond, I'm going to draw this part outside here. So you have carbon double bonded to carbon, and on top we have hydrogens, and on the side we have other carbons bonded. Bromine is bromine Br bonded to Br. That's Br2. What is going to happen? The bond in the bromine is going to break, and one bromine is going to come and attack this carbon, and the next bromine is going to come and attack the next carbon. This bond here is going to break, and one bromine is added here, the other bromine is added here. Right? So I'll end up with a structure where I have, instead of having a double bond here, I'm going to have bromine added here, and I'm going to have bromine added there. So bromine is going to be added across the double bond that is broken. So I'm looking for that structure. So it's not A, because this is the first and second carbon. It's supposed to be the second and the third carbon. It's not B. You have bromine on the second and the fourth carbon. That don't make sense. It's not C. You have bromine on the first carbon, and you have bromine on the fourth carbon. That don't make sense. D. You have bromine on the second and the third carbon. So the answer is most likely D, as in dog. All right, question 47. Which of the following substances is a product of a halogenation reaction with methane? All right, so how they expect us to know that? Okay, so let's see what is methane. Methane has the fractional formula CH4. So I have C with hydrogen, with 4 hydrogens bonded around. You have CH4. Okay, so methane is CH4, and they say which of the following substances is a product of a halogenation reaction. If we're talking about a halogenation, if you look at the word, you have halogen, so it's reacting with halogens, right? Halogens are chlorine, bromine, and iodine. So if I had chlorine reacting with this, it would be Cl2. So what is going to happen is the chlorine is going to split. You have Cl, Cl, and this is going to split to give me chlorine radicals. Right? So one chlorine comes and attacks the carbon, and hydrogen is lost, and it comes and binds with the next chlorine that remains. Right? It comes and binds with the chlorine. And when that happens, I have the formation of carbon tetrachloride eventually, not right away, but eventually. So I would start off initially with the first carbon, the first chlorine replacing hydrogen, right? Chlorine is going to replace hydrogen, so I'll end up with C with 3 hydrogens and a chlorine, right? Where would that chlorine have come from? Right here. The chlorine replaced the hydrogen. So I end up with CH3Cl plus H from here to give me H, and chlorine from the Cl2 to give me Cl. So I'll have 2 products being formed. CH3Cl is one and HCl is the other. HCl is the same as hydrogen chloride. So my answer to this question is C as in cat. Hydrogen chloride is a product of a halogen reaction. All right. C as in cat is our answer. Okay, so question 48 to 49. Item 48 to 49 refers to the following options. They give us 4 options and they tell us match each item below with one of the options above. Each option may be used once, more than once, or not at all. Okay, so and they want us to find an alcohol and an alkene. So we're looking an alcohol, we're looking for something that has an OH group at the end for the alcohol. And for the alkene, we're looking for something that has the formula CnH2n plus 2. All right, so let's see. A, B, C, D has an OH at the end. So D is probably the alcohol. All right, it doesn't have any other oxygens present, just an OH group. So D is an alcohol. An alkane. So let's try the first one, C2H4. That is C2, 2 2s are 4 plus 2. So A is not an alkane. C2H6. 2 2s are 4 plus 2 is 6. C2H6. So the answer is most likely B. B is the alkane, while D is the alcohol. So for 48, the answer should be D as in dog, and 49, the answer should be B as in boy. All right, question 50. Which of the following compounds can form a polymer? All right, so we have 2 types of polymers. We have addition polymerization and condensation polymerization. You have 2 types, addition polymerization and condensation polymerization. In order for us to form addition polymers, we must have an alkene, something with a double bond. In order for us to form condensation polymers, we need to have diacid and a diol. So we need to have an acid that have 2 acid groups, and we need to have an alcohol that have 2 alcohol groups. If you see a structure like that, then it's possible for condensation polymerization to take place. If you see an alkene, a structure with a double bond alone, then addition polymerization can take place. So let's look at the options they give us. Which of the following compounds can form a polymer? A can form a polymer because A has a double bond, so it's an alkene. B cannot form a polymer, it's an alkane. C again is an alkane, and D is an alcohol. We don't need an alcohol, we need a diol, something that have 2 alcohol groups. So if it had an OH on this side, then it might have been possible. So our only option right now is A as in apple. A is our answer. All right, question 51. The functional group present in carboxylic acids is, all right, so when we're looking for an acid, we're looking for C double bond O, OH. It can either be written like that, or it could be written as C double bond O, O dash H, or like that. Either structure is the functional group for a carboxylic acid. So when we see that structure, it tells us that that compound is an acid. So that is what we are looking for. C double bond O, OH. So here we have C double bond OH, but the oxygen is missing. So this is not our carboxylic acid. Here we have C double bond O, OH. Yes, this is our carboxylic acid. Here we have CHOH. This here we are dealing with an alcohol. So this is our alcohol, while the one on above is our acid. And down below here we have a double bond bonded to the OH group. So this is not our carboxylic acid. So the answer for 51 is B as in boy. B as in boy is the answer to 51. B as in boy. Okay. All right. 52. Item 52 to 55 refers to the following options. You have bitumen, paraffin, oil, methane, and propene. And they tell us, match each item below with one of the above options. Each option may be used once, more than once, or not at all. So 52, the residue in the fractional distillation of petroleum. When we have fractional distillation of petroleum, that is the crude oil in its raw form, just as we get it extracted from the earth's core, and that is bitumen, right? Bitumen is what is extracted from the earth's core, and that residue is placed into the fractional distillation column. And from that, we are able to get the different fractions, right? So that is bitumen. The answer to 52 is A as in apple, bitumen. '53. It is a major constituent of natural gas. The major constituent of natural gas is methane. Methane is the major constituent of natural gas, which is CH4. Methane is the major constituent of natural gas. Right? This here is what we use. This is also our cooking gas. This is what cows fart out, methane gas. In our landfills, when the gas builds up, the gas that builds up inside our landfill, again, is methane gas. Methane gas is a major constituent of natural gas. Okay? Next, is used in making plastics. Propene is an alkene, and an alkene could be used to make a polymer, addition polymerization, according to the previous question we were talking about a couple of questions ago. Alkenes can be used to make polymers, and plastics are polymers. Plastics are polymers. So propene, which is an alkene, could be used to make plastic because it is a polymer. It can create a polymer. Propene is an alkene, but we could end up with a polypropene, which is a polymer, and that is what it can be used to make plastics, right? It can be used to make plastics. So the answer to 54 should be D as in dog. Remember, 53, the answer is C as in cat, methane. And 52, the answer is A as in apple, bitumen. Question 55. 55, it requires the least amount of oxygen per mole for complete combustion. It requires the least amount of oxygen per mole for complete combustion. So we're looking for which structure has the least number of carbons in order for it to burn or combust, right? The structure that have the least number of carbons is the one that we are referring to. And when we remember naming carbons, we have methane, meth is 1, eth is 2, then prop is 3, and bute is 4. So met will have 1 carbon, eth will have 2 carbons, prop will have 3 carbons, and bute will have 4 carbons. Right? So bitumen is all the carbons. It hasn't been broken down as yet. So A cannot be our answer. It would require too much energy to break up bitumen. Paraffin oil is higher up in the chain, but it still has a lot of carbons present. Propene is an alkene, but prop has 3 carbons, while methane is 1 and it only have 1 carbon. So they say which requires the least amount of oxygen per mole for complete combustion. To combust means to burn. So therefore, if we want to burn something the fastest, methane, which only has one carbon, will burn faster than propane or propene, right? And the reason for that is because methane only has one carbon, while propene has three carbons, right? It's the same reason while a vehicle that uses diesel, the gas would take a longer time to run out in the diesel engine than if the person was using premium gas or super, right? The gas takes a longer time because diesel have more carbons present in it than the fuel, the premium fuel or the super fuel, right? Diesel has more carbons. So while the person who put in super gas in their engine is coming every couple of days to put gas, the person who is using a diesel engine can put gas at the start of the week and it can last them for the whole week, right? That's the difference between of them. Now, if you are driving a vehicle, do not go and put diesel gas inside of your super engine, right? What is going to happen to you is that you're going to mash up your engine and you will have to call a wrecker to wreck your vehicle home. So please, you need a diesel engine to run diesel fuel, right? Please don't go and tell your friends to change from super to diesel just like that. You need to change the engine so that it could support the fuel. All right, so coming back to the question, 55 requires the least amount of oxygen per mole for complete combustion, and the answer for this is C, methane gas, because it only has one carbon present. So it's easier to burn one carbon than it is to burn many carbon. So our answer here is C for 55. So 52 is A, bitumen. The residue for the fractional distillation of petroleum is A, bitumen. The major constituent of natural gas is methane. The one that is used to make plastic is the propene, can be used to make plastics. And the one that requires the least amount of oxygen to completely burn is methane. All right, 56. All right, just 5 more questions, people. A polyamide is formed by a condensation reaction between a molecule containing at least one COOH group with another containing at least one NH2 group. All right, so let me show you why that is so. When we talk about a polyamide, the word poly means many, and amide, I'm going to show you what an amide linkage looks like. Amide linkage is C double bond O bonded to NH. Right? Now, the C double bond O comes from C double bond O, OH, right? C double bond O, OH, and the NH here had another hydrogen attached to it. Right? The OH group from here was removed, and the hydrogen from here was removed, leaving us with NH and C double bond O. That's what it left us with, right? It left us with C double bond O and H. And this group that is formed here, this is your amide linkage or your peptide linkage. You find it in proteins. So it's your amide linkage or your peptide linkage. So when we have a polyamide form, we need to have a molecule that have at least one structure like this, a one acid structure, and we need to have another one that have at least one amide structure, NH2. So the answer to 56 is A as in apple. In order for us to form a polyamide, we must have a carboxylic acid group, which is C double bond O, OH, and we also must have an amine group, which is NH2. They would come together to give us a polyamide because of the amide linkage. This unit, C double bond O, NH, is going to be repeated over and over and over, making it a amide linkage. The hydrogen could be drawn on top or it could be drawn below. The oxygen could be drawn on top or it could be drawn below. It doesn't matter. It would be the same structure. All right. Next question. 57. 4 more questions, people. The compound ethene is described as being unsaturated. This means that the carbon atoms in ethene are linked by single bonds? No. Unsaturated doesn't mean single bonds. Carbon atoms in the molecule are very reactive? No. Unsaturated doesn't mean very reactive. Molecules have insufficient hydrogen atoms? No. Unsaturated doesn't mean insufficient hydrogen atoms. Molecules contain at least one double bond. Yes, that is it. They have one double bond. That is the answer. Double bond. Unsaturated means the presence of a double bond. Unsaturated tells us that a double bond is present. The compound ethene is described as being unsaturated because of the presence of a double bond. So the answer to 57 is D as in dog. Molecule contains at least one double bond. 58. 3 more, guys. Nylon is a macromolecule which is held together by the same linkage as a protein molecule. Nylon is a macromolecule. Macro is large or big. So nylon is a big molecule which is held together by the same linkage as a protein molecule. Now, a couple of questions ago, I told you that you could have an amide bond or a peptide bond. Inside proteins, you have peptides. So therefore, you could have a polypeptide or many peptide linkages. So they're telling you that inside the nylon, you have the same thing that you would have inside of the protein. And inside proteins, we have polypeptides or polyamides. So they ask you, what is the name given to this type of linkage? Oh, I give away the answer. The answer is A as in apple, an amide bond. And just to remind ourselves, that is the C double bond O, NH bond. Right? That is your amide bond. C double bond O, NH bond. Your amide bond. So the answer to 58 is A as in apple. A as in apple. All right, guys, we get nearing the end. 2 more to go. 59. Which of the following statements is true? The particles in a gas, let's start, are larger when heated. No, they're not larger when heated. They are further apart when heated. Yes, when you heat particles and there's a gas, they're pushed further away from each other because they want to escape and rise. So B looks correct. Are very closely packed together. No, that is a solid. They have strong forces between them. That is a solid. So the answer is B as in boy. When you heat gas, the particles are further apart. The answer to 59 is B as in boy. All right, and our final question for tonight is here. Question 60. Which of the following compounds can decolorize potassium manganate 7? Now, potassium manganate 7 is a purple substance. Potassium manganate is purple. And the only thing that would decolorize potassium manganate is an alkene. Not an alkane, not an alcohol, not a carboxylic acid, an alkene. Alkenes decolorize potassium manganate from purple to colorless. Alkenes changes bromine water from brown to colorless. Alkenes alone. The alkanes are unreactive and the carboxylic acid does not produce that color change. The only thing, the only elements that are able to do that, the compounds that are able to do that are your alkenes, not your alkanes, not your acids, not your alcohols, only your alkenes. So let's go to the question. Which of the following compounds can decolorize potassium manganate 7? Oh, A. A is an alkene. B is an alkene, so it would not happen. C is an alkene, so it would not happen. And D is an acid, C double bond OOH, so it will not happen. So the only answer to this question is A as in apple. It decolorizes potassium manganate 7. And that brings us to the end of today's session. So guys, any questions on that?